Hello everyone, I hope you all are doing fantastic today. In this video, we're going to be talking about what is encapsulation in C# and Unity. Let's begin. So, assuming that you know what are classes and objects, which if you don't, I highly recommend that you watch the previous episode of this tutorial series. Now it has come time to learn about one of the most important principles of object-oriented programming, which is encapsulation. So before we start talking about encapsulation, we first have to understand what kind of access modifiers there are in C#. So access modifiers are the keywords that allow us to specify the accessibility of a class, method, field, and etc. To explain each one of them, I've prepared this example, which is similar to the example from the previous episode of this tutorial series. And we're going to be basically using this person class, which is derived from the MonoBehaviour class. I had to change up some things from the previous tutorial because, well, this is deriving from a MonoBehaviour class, and I actually forgot to mention something from the last tutorial, and that is the fact that you cannot have constructors for classes that are inheriting from a MonoBehaviour. And the new keyword cannot be used on classes that derive from the MonoBehaviour class. Otherwise, you will get a warning saying that you cannot do that, and, well, it's not going to work. With that out of the way, let's start talking about the access modifiers of C#. So the first access modifier that we have is public. You can already see it being used over here for the person class, for the full name field, for the age field, and for this introduce method. What does the public modifier do? It basically allows you to expose your code to every single class in the project, and it can also expose the fields that we've marked public in the Unity's inspector, just like so. To prove you that we can use this in a different class, let's open up a different script that I have here, and what I'm doing here is I have this person field, and in the start event function, I'm basically assigning the full name of that person to Dan. We're allowed to do that because our full name field is public, as you can see. Next, we have the private modifier, which basically allows the code to only be accessible within the class where it is declared. So, for example, if we mark this full name as private, then as you can see in the person manager, we cannot assign a value to this full name field. That is because it is marked as private. But if we try to do it over here, then we will see that we will not get an error because we've marked this as private and it can be accessible in the class where the field is declared. If we mark this as private as well, and if we go ahead and just remove this from the person manager script, if we go ahead and go to Unity, we will be able to see that our fields have disappeared, and in fact they've not, they're just not shown in the inspector. That is because they are marked as private. So remember, if a field is marked as private, it will not show up in the Unity's inspector. The next access modifier that we have is protected, and it's basically kind of like private, but if there's another class which inherits from the person class, then in methods that this class has, you will be able to access the fields that are protected from the person class, just like so. And if we go ahead and go to Unity, those fields are not accessible from the Unity's inspector. That's because they're protected. And last but not least, we have internal. And internal is kind of like public, and it only allows the code to be usable or accessible in the assembly where it is declared at. And an assembly is basically a collection of types and resources. If you've seen file extensions such as DLL or exe, well, files with those file extensions are basically assemblies. They're basically like a package of types and resources. And by default in Unity, all of your scripts that you write, they're actually stored in the assembly-c#.dll assembly. Now you can definitely change the name of your assembly, and you can actually work with multiple assemblies. That is the reason why the internal keyword or modifier is useful, but I'm not going to cover that in this video. I will probably cover it in a later video. There are actually two more access modifiers. However, they're actually combinations of the modifiers that I've just mentioned. So it's protected internal, and then we also have private protected. And their use cases are very subtle. You might not even use them at all, but if you're interested to know what they might be useful for, I will leave a link to their explanations in the description down below so that you can check them out by yourself. But generally, they might not be even important to you at all. So those were all of the access modifiers in C#. So now that we've covered what are the access modifiers that are available in C#, let's finally talk about encapsulation. Encapsulation is basically the process of hiding sensitive data from users. So how do we encapsulate our data? Well, first of all, the principle of encapsulation says that we have to mark every single field that we have as private. And so you might ask, hey, what if we need to assign a field in a different class? Well, in those cases, we can of course mark the field as public. However, this will violate the rule of encapsulation. That is why you have to use something what's called a property. A property is basically like a variable and a method combined together. And properties can have two methods, which are called getter and setter. Some people may call it accessor and mutator, but generally it doesn't really matter. I like to call them getter and setter because they match the actual keywords that we're going to use right now in a property. So how do we declare a property? So to create a property, we need to write it as if we were writing a normal field, but in the end, instead of semicolons, we would have to put curly brackets. And inside of them, we can provide two methods. They have their own keywords, as I mentioned, which are get, and then you have to open curly brackets again. So this is like a function, and it needs to return some kind of value, which in our case is string. So let's return our field that we have right now in here called full name. And to write the setter, we need to write set, and then inside of the curly brackets, we need to write the full name field, and then we have to assign it a value using the value keyword. Now, this might be really confusing to you right now, and I can understand that. So let's go over this again, shall we? So this property right now is technically associated with this field, and to access this field we will be using this property. It's best to call the property the same as the corresponding field, just with the upper camel case naming convention. Inside of here, the get method basically returns our full name field, and the set method assigns the value that we will be assigning to this property to our full name field. So if I were to theoretically go ahead and go to the person manager and try to assign the full name to it, it will work. And in this case, our value is the Dan string. And when we're assigning the Dan string to the full name property, it is then assigning the then string into the full name field. And we can also appropriately get the full name just like so. And well, this will work just fine. So in a property, it's not always mandatory to have both a getter and a setter. You can have just one. And in that case, your property will become only read-only. And what that means is that you will not be able to use it to set your field. If you're within the same class where the field is declared, you can of course just set the field and so on like this. But if you were to do it in a different class, it's obviously not going to work. However, if you were to get it, as in, for example, printing it or assigning it to a different variable, then you can totally use it because you are not writing to that variable, you're only reading. You can also have write-only properties, and in that case, you'll only be able to write to that property, but you will not be able to get that property. As I'm doing in this case, you would have to use the field itself if it is declared in the same class as where you're trying to use it. And in a different class, it's not going to work. But if we try assigning something to it, then it will work just fine. We can also turn our property into something what's called an automatic property, which is basically a property without having a predefined field, which we have right here. So how do we do that? This is what you would call an automatic property. You can also have access modifiers for those get and set methods, and this can be really useful. For example, if you write private in front of the set keyword, then you will make sure that this automatic property will be able to be set only within the class, but it will not be able to be set in a different class. However, it can still be accessible, as you can see, because our get method is actually public by default. And so this can also be the same for the get method. However, I think the use cases for this situation are very subtle. So for the cases when you want to have a write-only automatic property, well, this is what you would actually use. So now you might be asking, well, is there something more that we can do with these properties? Something to note about automatic properties and properties in general is that you cannot edit them inside of the Unity's inspector. What that means is essentially if you want to have a public field which you do not want to be editable inside of the Unity inspector, you can use automatic properties instead. And generally, properties and automatic properties can allow you to have well encapsulated code. So now you might be asking, is there something more that we can do with properties? Well, yes, we can do much more in fact. In fact, let's try creating some kind of new field called nickname. So now let's try and write a property for this nickname. And let's just say that this nickname can contain only lowercase letters and numbers. And let's just say that, for example, this nickname is being set from different classes, for example. And instead of verifying and checking that the nickname is written correctly, we can use properties to validate that the nickname is being written correctly. So for that, let's create a property. Let's call it nickname, just with an upper camel case naming convention. And let's give it a both getter and setter. When we have the get method, let's return nickname. And instead of the set method, let's do some validation of the value that we will be setting to our nickname field. So I'll first create a new string. And so since our value is technically a string, and I'm talking about the value keyword for each character in the string, let's check if it's an uppercase letter. And if it is, let's set it to lower. And now let's also check if it's a letter or a number. And if it is, then let's add it to our string. And if everything else is false, then let's just throw an error. And the reason why I'm creating a new string over here is because, well, we cannot edit every character individually in this string, so that is why I'm creating a new string and basically appending a character every time that we loop through. So in this way, we are validating what kind of nickname is being set to this nickname field. Let's also modify the nickname getter right over here. Let's just say, for example, we want to have an address sign in the front of our nickname every time we get it. And in that case, we would basically concatenate an address sign to our string in front of it like this. Now let's actually test this out. So I'm assigning the nickname of DanTheMan123 to this nickname property, which will validate that string and then set it to the nickname field. Also, I am getting the nickname property, and it will actually run this getter when I'm actually getting the property from here. Let's try and run this in Unity. And as you can see, our nickname showed up appropriately. As we mentioned earlier, we wanted the nickname to have only lowercase letters and numbers. Now let us try and add some kind of symbol to this nickname. In that case, we will get an exception that we have written earlier. That is because we made it so that only letters and numbers can be in our nickname string. So that is how you can use properties to your advantage to encapsulate your code. Now what if I actually want to expose a field to the Unity's inspector? Do I always have to use the public keyword like this? Well, certainly not. You can use an attribute that Unity has made called SerializeField. Let's do the same for our age field. And so what this allows us to do is, regardless of the access modifier that this field may have, you will still be able to see those variables in the inspector, even if they're protected or even internal. So in cases when you want to expose a field, and if you're probably asking again, well, Dan, this is way longer than just writing public. Why would I torture myself by writing a lot more code when I could just write this instead of SerializeField in private? Why can I not just use public? Well, in this case, first of all, you're violating the rule of encapsulation, and second of all, this is totally up to you. If you prefer to write like this, then you can always use this because this will work just fine. But as your project may grow, you'd probably start having a lot more classes and a lot more fields, and if they're all public, then it might be hard to control their usage, right? And so this is why we need to mark everything as private at first. So that's it for this video today. I hope y'all enjoyed it. I hope you were able to learn something new about encapsulation, about Unity or C#, whatever it may be. Please leave a like if you enjoyed the video, and please subscribe if you're excited for more content like this. And if you have any questions, do not hesitate to ask them. I will try to respond as fast as I can. And thank you so much for watching this video. Goodbye.